Good morning, students. Our today's topic is Mendeleev's periodic law. Students, the first real breakthrough in the classification of elements was provided by Russian chemist Mendeleev. He has been regarded as the main contributor to the early development of the periodic table. So first of all, we should also know what is periodic table. Student, a periodic table may be defined as an arrangement or a chart which classifies all the known elements on the basis of their properties in such a way that the elements with similar properties are placed in the same vertical column. Correct? So this kind of chart is exactly called periodic table. Now we are coming back to the Mendeleev's law. Student, when Mendeleev started his work on classification, only 63 elements were known. He tried to correlate the atomic masses of the elements with their physical and chemical properties. And on the basis of these similarities in the properties, Mendeleev proposed his periodic law. Thus, Mendeleev's periodic law states that the physical and chemical properties of elements are a periodic function of their atomic masses. Or we can also say, when elements are arranged in order of their increasing atomic masses, elements with similar properties are repeated after certain regular intervals. This repetition of properties of elements after certain regular interval is called periodicity of properties. Students, Mendeleev arranged these 63 known elements in increasing order of their atomic masses in horizontal rows and in such a way that the elements with similar properties fell under the same vertical column called groups. So here you can see the periodic table of Mendeleev's. Look at the feature or characteristics of this table. This table consists of 7 horizontal columns called periods. These are actually numbered from 1 to 7. Then it also consists of 8 vertical columns called groups. Each group is divided into 2 subgroups called A and B. Here we should note this, that the noble gases were not known at that time of Mendeleev. Therefore, there was no group of noble gases in this periodic table. So these are the feature or characteristics of Mendeleev's periodic table. Now we are coming to the very important topic, what were the achievements of Mendeleev's periodic table. Now the first very important achievement of this table is systematic study of elements. Student, Mendeleev was the first scientist who arranged the then known elements into groups and periods. This made the study of elements quite simpler, because if the properties of one element in a particular group were known, those of others could be easily predicted. Right? Further, while developing the periodic table, Mendeleev kept 2 things in mind: increasing atomic masses and grouping of similar elements together. So this was the first biggest achievement of Mendeleev's periodic table. Second was correction of doubtful atomic masses. Student, Mendeleev's periodic table helped in correcting the doubtful atomic masses of some elements. For example, beryllium was actually assigned an atomic masses of 13.5 on the basis of its equivalent mass and valency. Now think about this, if beryllium has an atomic mass of 13.5, then it should have been placed between carbon and nitrogen, because the atomic mass of carbon is 12 and nitrogen is 14. But No vacant place was available between the carbon and nitrogen. Further, properties of beryllium were similar to those of magnesium and calcium, which are placed in the group second A. Therefore, valency 2 was assigned to beryllium, which gave it an atomic mass 9. As a result, beryllium was placed in proper position between lithium and boron. So this was another biggest achievement of the Mendeleevs. Now the next achievement, prediction of new elements and their properties. Look at this table. Mendeleev left some blank spaces or gaps, which you can see in this table. In the table for those elements which were not known at that time. He also made the bold prediction that these elements would be discovered in due course of time and would fill the blank spaces. He even predicted the properties of these elements. So this was also a great achievement. Next was the position of noble gases. Student, the noble gases like helium, neon, argon, krypton, radon, these were not known that time. These gases were actually discovered much later because they are very inert. Okay, so and the present in extremely low concentration in our atmosphere. So another strength of this periodic table was that when these gases were discovered much later around the year 1900, they could be placed in a new group called zero group without disturbing the existing order. So these were the very important and great achievements of Mendeleev's table. Now we will talk about the limitations of Mendeleev's periodic table. The first limitation was anomalous position of hydrogen. Student, hydrogen has one electron in its only shell, correct? Therefore, many properties of hydrogen are similar to those of alkali metals. Thus, hydrogen can be placed along with alkali metals of group first A in periodic table. Correct? In other words, we can also say it has one electron which is just less than the nearest noble gas helium. Halogen, we know the halogen on other hand have 7 electrons in the outermost shell. Okay, so like hydrogen, halogen also have 1 electron less than the nearest noble gases. Therefore, many properties of hydrogen are similar to those of halogens. So, we can also place the hydrogen with the halogen also. So, in other words, we can say position of hydrogen in periodic table is controversial. No fixed position can be assigned to hydrogen in the table. So this was the first limitation. Now second was the position of isotopes. Actually the isotopes were discovered long after Mendeleev gave his periodic table. Now we know that what are the isotopes. Let me clear one more time that isotopes are the atom of the same elements having similar chemical properties but different atomic masses. Correct? So in this table, for example, hydrogen has 3 isotopes, protium, deuterium and tritium. This we have already discussed, having the atomic masses 1, 2, 3 respectively. Similarly, carbon also has the 3 isotopes, chlorine also has the 2 isotopes. Since in the Mendeleev's periodic table, elements are arranged in increasing order of atomic masses and isotopes of an element have different atomic masses. Therefore, they should be placed at different position in the table. So this was actually not clear in this table. Next was the anomalous position of some pairs of elements. Although the elements in the Mendeleev's table have been arranged in the increasing order of atomic masses, yet in some cases, elements have been arranged on the basis of their properties, similar properties. As a result, an element with higher atomic mass has been placed before an element with lower atomic mass. For example, look at this table. Cobalt with higher atomic masses What is the atomic mass of cobalt? That is 58.93. Okay, it has been placed before nickel with the lower atomic mass 58.71. So these kind of 2 or 3 exceptions were there in this periodic table. Next, different groups for similar elements. So in some cases, elements with similar properties have been placed in different groups. For example, both again that copper and mercury have many similar properties, but copper has been placed in first B while mercury has been placed in the second B. Then one last limitation of this table was uncertainty in prediction of new elements. In periodic table, the elements are arranged in increasing order of their atomic masses, correct? But the atomic masses do not increase in a regular manner in going from one element to the next, that we all know. Further, the difference in atomic masses between two successive elements is small among lighter elements but large among heavier elements. Therefore, it is not possible to predict how many new elements could be discovered between two known elements, especially among heavier elements. So these were the some limitations, but still we can say that the Mendeleev, this periodic table, put a great mark on this classification of elements.